Imagine a cloud in space so massive that it contains enough alcohol to fill trillions of bottles of wine. Not on Earth. Not on another planet, but floating in deep space, near the center of our galaxy. A cosmic cloud so enormous that if humanity could somehow collect it, it would supply alcohol to every human civilization for millions of years. But this discovery raises an even stranger question. If space can naturally produce alcohol, what other bizarre chemistry might be happening out there? Today, we're exploring one of the strangest discoveries in modern astronomy, the giant alcohol cloud in space, known as Sagittarius B2. And trust me, this story gets weirder the deeper we go. In the early 2000s, astronomers studying the center of the Milky Way began observing a massive molecular cloud located roughly 26,000 light-years from Earth. This cloud was already known to scientists as Sagittarius B2, one of the largest and densest molecular clouds in our galaxy. But when scientists analyzed the light coming from this region using powerful radio telescopes, they discovered something completely unexpected. The cloud was filled with complex organic molecules. Among them was something surprising: ethanol. Yes, the same type of alcohol found in beer, wine, and spirits on Earth. At first, scientists were skeptical, but after repeated observations using radio astronomy, the evidence became undeniable. The cloud truly contained vast amounts of alcohol molecules floating freely in space, and the scale of it is almost impossible to imagine. When astronomers calculated the total amount of ethanol present in Sagittarius B2, the numbers were staggering. The cloud contains enough alcohol to produce approximately 400 trillion pints of beer. To put that into perspective, if every human on Earth drank 1 billion bottles per day, it would still take millions of years to consume it all. But here's the important detail. This is not drinkable alcohol. In fact, the alcohol molecules are spread extremely thin across a gigantic region of space. The cloud itself spans hundreds of light-years across. So while the total amount is enormous, the molecules are incredibly dispersed. Still, the existence of alcohol in space raises a fascinating scientific question. How can such complex molecules form in the vacuum of space? To understand this, we need to look at how chemistry works in interstellar clouds. Regions like Sagittarius B2 are known as molecular clouds. These are enormous cold regions of gas and dust where new stars are born. Inside these clouds, temperatures can drop to around -260 degrees Celsius. Despite the extreme cold, chemistry is still happening. Tiny dust grains floating through the cloud act as chemical laboratories. Atoms and molecules freeze onto their surfaces. Over time, these particles interact with radiation from nearby stars and cosmic rays. These interactions trigger chemical reactions. Slowly, simple molecules begin to form more complex ones. Hydrogen plus carbon plus oxygen can combine in many different ways. Eventually, these reactions can create organic molecules such as methanol, formaldehyde, acetaldehyde, ethanol. In other words, space itself can naturally produce the building blocks of alcohol. Out of all the molecular clouds in our galaxy, Sagittarius B2 stands out for one reason. It is one of the richest chemical environments ever discovered in space. Astronomers have detected over 60 different molecules in this cloud. Some of them are surprisingly complex. These include glycolaldehyde, ethyl formate methyl formate, ethanol. This discovery has enormous implications for science, because many of these molecules are related to prebiotic chemistry. That means they could play a role in the formation of life. The discovery of complex organic molecules in space suggests something incredible. The ingredients for life might not be rare. They might actually be everywhere in the universe. Many scientists believe that organic molecules formed in interstellar clouds long before planets even existed. When new solar systems form, these molecules can become trapped inside comets, asteroids, planetary atmospheres. Later, impacts from comets or meteorites could deliver these molecules to young planets. Some scientists think this may have happened on Earth. Organic molecules from space could have contributed to the chemical processes that eventually led to life. If that idea is correct, then regions like Sagittarius B2 may represent cosmic factories for life's ingredients. The idea of a giant alcohol cloud floating in space naturally leads to a fun question. Could humans ever collect it? Unfortunately, the answer is almost certainly no. Sagittarius B2 is located about 26,000 light-years away from Earth. Even with our fastest spacecraft today, reaching it would take tens of millions of years. But distance isn't the only problem. The alcohol molecules are incredibly spread out. If you try to collect them, you would need to harvest material from a region larger than our entire solar system. So while the total amount is huge, the actual concentration is extremely low. In other words, it's more like a faint cosmic mist than a giant floating lake of alcohol. Sagittarius B2 is only one example of how strange space chemistry can be. Over the past few decades, astronomers have discovered many unexpected molecules across the universe. Some of them include sugar molecules, antifreeze chemicals, complex hydrocarbons, amino acid precursors. In fact, more than 200 different molecules have now been detected in interstellar space. Each discovery helps scientists better understand the chemical processes that occur between stars, and every new molecule brings us closer to answering one of the biggest questions in science. How did life begin? When we look up at the night sky, the universe may appear empty, but in reality, space is full of invisible chemistry. Gigantic molecular clouds drift through galaxies like slow-moving cosmic oceans. Inside them, atoms collide, combine, and transform. Over millions of years, these reactions build increasingly complex molecules. Eventually, these clouds collapse under gravity and form new stars and planets. And the molecules created in those clouds may end up on the surfaces of those planets, which means something remarkable might be true. The chemistry that leads to life might begin long before a planet is even born. The discovery of alcohol in space reminds us of something important. The universe is far stranger than we once imagined. A century ago, scientists didn't even know molecules could exist in interstellar space. Today we know that space contains organic chemicals, complex molecules, the ingredients for life, and possibly much more that we have yet to discover. Somewhere in distant molecular clouds, new combinations of atoms may be forming molecules we've never even seen before. The universe is constantly experimenting with chemistry on a scale far beyond anything on Earth. So the next time someone says, "There's nothing interesting in empty space," remember this. Floating near the center of our galaxy is a cloud containing trillions upon trillions of alcohol molecules. A reminder that even in the cold vacuum between stars, chemistry never stops. And who knows, somewhere out there, inside another giant molecular cloud, the chemical ingredients for the next form of life might already be forming. If you enjoyed this video about strange discoveries in space, don't forget to subscribe for more cosmic mysteries and science explained, because the universe is filled with incredible secrets, and we've only just begun to discover them.